You might have heard about Uber's search pricing engine or Netflix recommendation engine or even this Amazon's order pipeline. Okay. In all these systems, there are thousands and thousands of records are coming at the same time, simultaneously. Okay. And how you ever wondered what are the common thing between these three engines? Okay. All these three engines are handling huge amount of requests per second. They all have one thing in common, that is the message queue system. Yeah, how they're handling this huge amount of messages without losing any of them. The common application they use is Kafka. This is a service called Kafka. It is developed by LinkedIn in 2011. This developed by LinkedIn in 2011. Later then they outsourced it. They made it open source. And what is meant by Kafka? Kafka is a message queue system. It's not just a message queue system, rather than that, it's an event queue system. And we can do scale out. Scale out means whenever there is a request, high request is there, we can add more Kafka broker into the system and we can scale out. That is one advantage of Kafka. The another thing is the Kafka is fault tolerant. This is a Kafka is a message queue system. It is more than a message queue system. We have a distributor log, and it is horizontally scalable. It is horizontally scalable and it is fault tolerant. It is fault tolerant. And before Kafka, what was happening is before 2011, whenever there is a service, if you have one service, suppose I have one service called order, okay, order service there. The order service, I have payment service, payment service, I have inventory service, and I have something else called analytics service. And suppose I have order and I have product. I have two services are there. Two services are there, and it is connected to uh, each other. Okay, before Kafka, they had to create separate endpoint from these two services. Whenever there is a new services coming in, they have to rewire everything from beginning. That if X Y Z product has came, then again they need to do this rewiring from this service to the end service. If you have end service layer here and then endpoints are here, then the total complexity of connection will be n by m. That is going to be a complex one. Later, they have discovered the Kafka. Okay, Kafka, what it will doing? All the services, I can say it as producer. Okay, these producers produce the messages. Okay, messages or events, and they push it to the push to Kafka. Push to Kafka means they will create a topic. It is called topic. The topic is its own name. Some topic name will be there, and that topic, whomever want that topic. Okay, suppose I have topic one TP1, TP2, TP3. I have P1, producer 1, producer 2. Okay, I have producer 1 and producer 2. I have TP1, TP2, and TP3. Whomever want to get this data, they can subscribe here. Okay, from here there'll be this is called publishing. This is called publish. Once it is published to the uh, topic, then anyone can do subscribe. Anyone can subscribe. There will be many, these are called, whomever is subscribing this topic, they are called consumers. Consumers. Or it can be a consumer group. Or consumers or consumer group, we can call it as. And whomever, suppose one consumer group can subscribe to more than one topics, and they all will get this data. This is how this Kafka is working. Let's go ahead and see what is the architecture of Kafka. Architecture means we have producers are here. Producers, okay. Producers, then Kafka cluster, then we have consumer. Producer P1, P2, P3. Okay, sometimes this producer P1, it will be some clickstream data. P2 will be some order data. P3 will be some sort of any other events. Okay, then we have this Kafka cluster. What is there inside the Kafka cluster? Kafka cluster is composed of servers. Those servers are called brokers. Broker 1, broker 2, broker 3. Usually 3 brokers or 3 to 5 brokers will be there. Inside each broker, we have something called, inside this broker will be having topics. Okay, topics means it is a named entity into which this data will be published. Named entity into which this data will be published. P0, P1, P2, P3, etc. This data will be published. This is called TP1. Okay. Inside the topic, we have something called partitions. Inside this topic, we have something called partitions. We have inside broker, we have topics, TP1, TP2, etc. And for each topic, okay, okay, I can have n number of partitions are there. Topic is divided into partitions. Suppose there will be P0, P1, P2, P3, etc. Like that, we have a number of partitions will be there. Actually, this partitions P0, P1, P2, P3, these partitions are giving the power of parallelism. Power of parallelism for Kafka service. And these are the major components of Kafka. Okay. Then from this topics, there will be consumer, or we can call it as consumer group. Okay, we can call it as consumer groups. We can call it as CG. Okay, here we'll be having CG1, CG2, CG3, etc. They can subscribe to any of the topic 0, topic 1, topic 2, topic 3, from anywhere they want, which topic they need. Depend upon that, they can subscribe to those topic. That means that message they can subscribe. This is how this Kafka is working. How it is getting controlled and coordinated. For the coordinator service, okay, we have Zookeeper coordination. Zookeeper is doing this, all the controlling and coordination of all these brokers. Okay, this is how this Kafka cluster is working until now. Now we have another concept in Kafka. Another concept in Kafka that is called, instead of Zookeeper, they start using another protocol called Raft protocol. Okay, Raft protocol. Okay, Raft. You can say it is algorithm. Okay, it's Raft consciousness algorithm. Consciousness algorithm. It is called Craft. It is called Craft. What it is doing, instead of Zookeeper, earlier we have Zookeeper coordinator services, Kafka services. Here we have producers. Okay, then we have number of Kafka brokers, and inside this Kafka broker, they select three of them are controllers. Okay, controllers. It will be either three or five controllers will be there. It is called control plane. Three or five controllers will be there, and this is called Craft. Okay, they are using, in Delhi they are using Craft protocol to do this control and coordination, and this is within the cluster itself. And then will come this consumers. Then come the consumers. Here there is no Zookeeper. There is no Zookeeper control and coordination. There is no Zookeeper. So that whenever there is a Zookeeper is there, okay, whenever there is a Zookeeper is there, okay, the failover latency will be in 100 to 200 seconds, okay, milliseconds. Failover latency will be 100 to 200 milliseconds. Whereas with Craft, this failover latency is less than 20 milliseconds. Less than 20 milliseconds. This, if there is any happen to the leader, immediately it will switch back to the another leaderboard. This is what this failure is. If it is a Zookeeper related, then 100 to 200 millisecond is the the latency. Whereas if it is a Craft, the failure is less than 20 milliseconds. That much fast it is. On the upcoming version, that is from Kafka 4.x version onwards, there won't be any Zookeeper. There's only Craft. Okay, Kafka 4.0 onwards, only Craft. And no Zookeeper. Okay, there is no Zookeeper form for Kafka 4.x onwards. Let's go ahead and see each component and its internal architecture once again. We are going to see what is producers. We're going to see what is producers, what is consumer, what is partitions, and what is topics. There are other components, not components, some concept called offset values and partitions and all in sync replica. We are going to see one by one and how it is going to help us in maintaining the fault tolerance and all. Let's go ahead and see this architecture. Okay, let's see what is the core component. Core component, if you see, this is what is Kafka? Kafka is a distributed event streaming platform, as I have already given. Apart from event streaming platform, it is distributed event system. That means these events will be shared persistently in the data store or disk underlying hard disk. It will be shared, and we can go back to the previous history. Whenever, suppose if you want to go to the 1 week back history or 1 month back history, we can go back to that history. That will be depend upon how much data we are retaining. Second thing is horizontally scalable. We can add more number of brokers into this Kafka system, and we can horizontally scale out horizontally. It is fault tolerant. Failure of one node is not going to bring the Kafka service down. We can get the data from some other node. That's why, because we are having something called replication factor from that. That means whenever there is a data written through Kafka topic, that will be replicated 3 times. If in some times one node goes down, we can get the data back from the other two nodes. First of all, let's go ahead and see what is meant by producer. Okay, producer, they are the one who produce the data or create the events and publish those messages into Kafka topic. As I already told, all the messages or all the event will be written into topics. Who is doing that? The publishers are going to do this event streaming into this topic. Then come to the consumer. Okay, this is how we are creating this producer. Okay, so we have this producer. Suppose if a consumer want to get the details, they have to subscribe to this topic. This is the topic name we are giving. This topic. All the order event has to go to this order topic. When some consumer want to subscribe to that order events, they have to consumer.subscribe. They have to give that specific name of the topic. Here it is orders. We have another concept called broker. There are Kafka servers who store all this data, all the events into this. So these are called the Kafka brokers. Okay, we can start using Kafka server start.sh, and we need to specify any server properties. We can specify the server properties file. Next thing is called this topic. Okay, topic is a named entity to store any Kafka event. While we creating this topic, we'll be creating one more thing called partition. How many partitions are required for that particular topic? That means, suppose if I want 3 partitions in the Kafka cluster, it will create 3 partitions for that particular data, particular topic. And these partitions are actually give the parallelism for Kafka cluster. And then we can go ahead and see this cluster architecture. If we see this cluster architecture, I have always really shown what are the major components of Kafka. Here, initially, we have this producers are there. We have major 3 components. We have producers, we have Kafka cluster, then we have consumers. These are all controlled and coordinated using Zookeeper or KRaft. If it is a Zookeeper, then it's an external coordination. If it is a KRaft, then it is coming within inside this Kafka cluster. Let's go ahead and see this architecture of Kafka using KRaft. KRaft means it's a Kafka with a Raft protocol that is called this KRaft. In KRaft protocol, we're using KRaft. Like before, we have this we have producers are there. Okay, then and then we have consumers are there. We have the Kafka clusters also there. Apart from that, few of the brokers will be selected are as controllers. Few of the broker will be selected as controller. Usually 3 or 5 odd number of controllers will be selected. Instead of controller, previously we are having Zookeeper. Okay, Zookeeper will have three or five number of zookeeper. There's a zookeeper quorum election and all. Like that, we have controller now. And in the control itself, we have active leader and followers will be there. One leader and two followers will be there. And they are doing all this controlling and coordination of the Kafka services. What is the benefit of this controller using KRaft or Craft instead of Zookeeper? The latency is minimized because earlier the Kafka has to go out of its service line and get all its metadata from Zookeeper. Now all the metadata about about this Kafka service is residing in Kafka itself as a separate topic, and so that whenever there is a failover is happening, leader election is happening, the process is very fast. In less than 20 milliseconds it is happening, whereas in previous stage it was taking around 200 to 300 milliseconds or 100 to 200 milliseconds, we can say. That latency can be avoided. That is the major advantage of using Craft cluster instead of Zookeeper cluster for handling Kafka. Another important concept in Kafka cluster is what is meant by this topic, partition, and offset. Topic, as we know, is a named entity. What are the producers creating the events that will be published into topic? We will be specifying how many partitions we require. Inside each partition, data is in an order, that is an ordered, and not only ordered, that data is immutable. Each chunk of data is having its own offset value. It's an ordered pair, immutable, and having offset value. Three partitions: partition 0, partition 1, and partition 2. This is the command to create any topic. Hyphen hyphen topic name, and number of partitions we are specifying here. Like that, if you specify the partition, that many amount of partitions will be created for a particular topic. Like that, it has created three partitions. We have already seen the topic, how we're creating topic using command line. That is hyphen hyphen topic name. Then we need to specify number of partition, hyphen hyphen partition, number of partitions required. Suppose I have created three partitions for a particular topic. Okay, that is partition 0, partition 1, and partition 2. And my data will be going to be saved inside these partitions. This all partition is a part of the topic called order topic. Okay, order topic, it has three partitions, and the replication factor is 2. That inside the partition is a fixed length size data. We have data 1, data 2, data 3, data 4. It will be like this. Inside this data is immutable. First of all, it is immutable. You will not be able to change it once it is in Kafka. Second thing is it's an ordered value. It is having a value. It is called offset value, offset 0, offset 1, offset 2, offset 3. Inside each partition, this data is in a ordered manner. If you see in partition 1 also, there will be offset 0, offset 1, offset 2. Similarly, for partition 2, it is offset 0, offset 1. This is how this message will be queued inside this broker. This is how this partition is being arranged inside this topic. We have partition 0, partition 1, partition 2. Then let's go ahead and see another important component. Known is replication, how this replication is happening. Each partition has one leader and n-1 follower. N-1 follower means usually if it is a partition, I said it is a 3, then one leader and two followers will be there. These followers are called ISR or in sync replicas. Okay, these ISR are required whenever there is a failure is happening. The Kafka will be looking into this ISR or in sync replicas. For this, suppose if the partition broker 1 is the leader for P0, broker 2 is the follower for P0, and broker 3 will be follower for P0. P0 is the partition 0. Like that, for partition 1 also there will be one leader and two followers. Partition 2 also there will be one leader and two followers. Okay, then comes to the next topic, that is called this consumer group. Consumer group means that is the end of the Kafka service line. That is who is consuming this data. we are creating this data, that is the producers are creating the data, then pushing it to this topic inside this Kafka broker. Now someone has to take this data and process the data. Those are called consumers or consumer group. Suppose the event has been created by the order, then the payment group has taken this order, then they'll process the payment. That is a consumer group. The analytics team has taken this details of the orders which is happening daily. Then analytics team will be another group. These are called consumer or consumer group. Okay, group payment service. This is a consumer group. This is all about Kafka architecture and its internal component. We have seen the difference between Kafka with Zookeeper and Kafka with Raft protocol. This will be the remaining, all these things will be same. Only difference is that in Raft related one, in Raft Kafka, we are using Raft consciousness protocol instead of Zookeeper. Let's go ahead and see this in practical. I'm going to spin two clusters. One is using um, Kafka with Zookeeper, and another one is with Kafka with Craft protocol. And we are going to create few events. We'll see how producers are producing the events and how the consumers are consuming these events. We are going to see both of them. Let's go ahead and spin up the cluster. Here I have two folders, one with Kafka with Craft and another one is Kafka with Zookeeper. First of all, we are going to see this traditional one, that is Kafka with Zookeeper. Let's open this README file for Kafka with Zookeeper. And let's proceed to do what it is mentioned. I need, let's close this unwanted tabs, and I may need two window. One is for consumer and another one is for producer. Here, and before that, I'm going to enable virtual environment for running this application. This is the architecture producer. It will be giving or publishing data to Kafka broker, and it will be taken by the consumer. All are controlled and coordinated by Zookeeper. Then let's go to this directory. Now we have the Kafka Zookeeper. Then we are going to spin up the cluster using Docker Compose. Let's go ahead and see whether it is bringing the Docker Compose or not. It started. Let's see the container. We have this Kafka Zookeeper. If you see the container, we have two containers. One is Zookeeper, another one is Confluent Kafka. This is a single instance for demo. Let it be there. And we need to enable this virtual environment. Okay, enable this virtual environment on both this terminal. Okay, now it is VNV. Both the case I am using, cd Kafka Zookeeper, then enable VNV. Okay, clear the screen. The first one, I am using this one as a consumer, this one as a producer. These are all already installed. I was testing it. Topic is already installed. If you want, I can show you. Let's see whether it is created or not. Let's see whether it is created or not. See, Python topic Uber ride events is already there. We have this topic called Uber ride events. So now I am going to start the consumer first. Before starting the producer, there should be a consumer. They are ready to consume that data. They'll be always open to receive the data which is produced by the producer. Then I'm going to spin up this Python file. It is called consumer.py. Now the consumer is ready. It is ready to accept the events from the producer. In the other end, I have opened another terminal. This is called the producer. Producer is going to produce Uber service event, Uber drive events. It is going to create around 20 events. It is going to create and sending to the consumer. See what's happening. Whatever is produced by the producer will be consumed by the consumer. It is going through this Kafka service. See the magic. Whatever is produced here, it is consumed at the consumer end. it has created around 20 events, and the producer closed the event. Once the producer complete this task, consumer producer will close its events. But the consumer end, it is still ready to accept the further events. Suppose if another event happening here, again it will be ready to accept the next event. See, it is ready to accept. That means consumer will be always open to accept any event which is coming in, but the producer can close the events whenever it is finished. This is the demonstration of Kafka using Zookeeper. Next, what we are going to see is the demonstration of Kafka without Zookeeper. There we are going to see Kafka with Craft protocol. Let's close this one. I'm just going to delete this two terminal. That will kill those services. And I'll be stopping this Kafka super instance I have stopped. Let it be there. Now I am going to Kafka Craft. Okay. In Kafka Craft, there is a separate README file, and opening that file and opening the terminal. Here also I need two terminal. Okay. So just press Control B to close this left side panel. Now we have two terminal. Here also I will be having producer and consumer. Left side it will be consumer, or right side it can be consumer. This one is producer. Here the architecture, if you see, we have the producer. There is no Zookeeper here. Kafka broker plus controller. Here we have and consumer. How we are running? The running will be same. We need to go to this directory on both this terminal, and then we need to, I'm going to bring this service up. Need to run on any of the one node. Once it is done, we want to see this Docker Compose PS whether it is running or not. Just copy this and and execute this. It will show the running command Kafka Craft demo. Now it is running using demo Craft protocol, not using regular Zookeeper. Now, if you want to see the log, you can see the last 30 lines of log. It will show all the logs. Okay. Let's go ahead and enable the virtual environment. Not Control L, it won't work. Okay. Clear. Now, I'm going to enable this virtual environment. Command is same. And I need to execute on both the sides. Once it is done, let's see whether there is, we can try to create the topic. Okay. See, yeah, there is a topic already. Names Netflix view events. One topic is already there. Then now we are going to see, we are going to enable this consumer on one side. We are enabling the consumer here. Yeah, consumer is ready. Now we are going to produce some input, or we are enabling producer. This producer will create few events and it will be subscribed by the, it's already subscribed by the consumer, and it will go to that consumer. Let's press enter. It will be creating around 20 events, Netflix events in the producer side, and it will be consumed by the consumer end. See the magic. See, it has created few Netflix events. Is pause, resume, add to list, complete, add to list, resume, complete. Like that, these are all the event. Whatever we do in Netflix. So suppose if you are resuming, or if you are playing, or add to favorite list or something, these are all events. These all events will be taken by the Netflix team or Netflix engine by Kafka. It is going through Kafka, and it will be consumed by the other end. And Netflix is taking all this information to do their recommendation engine, and collaborative filtering and all other machine learning and artificial intelligence work for doing their business. This is how this uh, Kafka is working with Zookeeper and without Zookeeper and using Craft protocol. And if you see, let's go ahead and see whether it is running with, yeah, where is Kafka Craft? If you see, we have only one instance, Kafka Craft demo, only one instance is running. This is all about the demo and the theory about the Kafka service. It's a distributed event service, as I said, and not really event or queue system. It is a distributed log. That means this data is getting saved in the storage file system of Kafka broker. And whenever there is a huge spike is there, we can horizontally scale out this Kafka cluster. That is how it is achieving high throughput. And the next thing is fault tolerance. As parallelism is done using partitions. Whenever we create a topic, we will be specifying how many partitions need to be created. That partition we can specify, and those can be those partitions will be residing in different Kafka brokers. And this is all about Kafka, and I have shown you this Kafka architecture, how Kafka is working, what are the components of Kafka, what is maybe topic. Inside topic, we have number of partitions are there. These partitions are actually giving the parallelism for Kafka. And this is highly fault tolerant because if something happens to one broker, we can recover this data from the other two brokers. This is all about Kafka. Thanks for watching this video. Have a good day. Bye.